Okay, I'm also recording. So again, we go to share. Okay, you got it? You got this?
Yes, sir.
Okay. So this is what is glucose structure. But we have not established the structure. We have to establish the structure. We have to come bring structure. That is what is our idea in today's class. That will let us see whether how much we can do. To remember the structure, you have to remember this the structure of glucose. There are four chiral centers, 2, 3, 4, 5. These are these carbon atoms. So you have to remember it like this: right, left, right, right. And then other structures you just remember with respect to this glucose. So fructose will be ketohexose, but here fructose is negative. Just see, negative means it is liver rotatory, but it is destructured. Destructure is because of this OH groups on the right hand side, because that is related to glycerol. Another important structure is mannose, plus mannose, D plus mannose, then also lactose. Then another molecule that you should remember, that of ribose. Ribose is aldopentose. Okay, where these three chiral centers, the OH group is on the right hand side in Fischer relation. Now we come to today's class. We will come some important reactions. That not that reactions are for your MSc class it is important, but this will be necessary to. Now, what this reaction? The reactions will depend on what is the functioning group present there. So it has got a functioning group aldehyde, as we see from here. It has got aldehyde group, and there are 5 OH groups, right? And so it will show the properties of this aldehyde and also that of alcohol. So one of the property of aldehyde is that it gets oxidized. So the first reaction that we take, bromine water. Bromine water is a mild oxidizing agent. So what we'll get? The aldehyde group will get oxidized, right? So we get this gluconic acid. That's aldehyde group becomes COH group. Everything remains, other thing remains same. So that is now also we know Tollens reagent. Tollens reagent and Pelling solution are also oxidizing agent, mild oxidizing agent. They also will oxidize. So glucose will respond to the test of Tollens and Pelling. This is Tollens reagent and Pelling solution. What are they? You know it. I'm not writing and not doing anything. So that is also going to oxidize glucose to give you the gluconate, not gluconic acid, rather gluconate, because this is the both Tollens and Pelling solution are in basic medium. So base will take away this proton and this is the acid. And when it is Tollens reagent, we get silver mirror. And when we get Pelling solution, do it with Pelling solution, we get red cuprous oxide. That is what you know it. So I'm not spending time on this. Another reaction because of the carbonyl group NH2OH. NH2OH, what it is going to do? Tell me, somebody. Somebody. Tell me, somebody. Huh? NH2OH, what reaction it is going to do? What is going to give us?
So H2O will get removed.
So what is the product?
NOH, C double bond NOH.
What it is called? It's called an oxime.
Yes, oxime.
Oxime. So from glucose we are getting like glucose oxime. This is what we'll be getting. This NOH of this H2O will go out and NOH will get. So this is oxime. So remember that means it is also so this is also showing that it is an aldehyde group, because aldehyde it is reduces Tollens reagent. So it is an aldehyde. At the same time, it is also showing that it is a carbonyl group. So these are positive test for this. With HCN, HCN also is a reagent which will react with the carbonyl group. It gives cyanohydrin. So with this we get cyanohydrin here, CN and CHOH. This will become carbonyl group will react. So we'll get glucose cyanohydrin, right? But with phenyl hydrazine, we get some unusual products. 3 equivalent excess of phenyl hydrazine when we use. What do you remember? Anybody who can tell what is the product we get? If we take 1 equivalent of phenylhydrazine, this aldehyde group will react to give you phenylhydrazone. But if we take excess of phenylhydrazine, in this case, there is a special reaction. What do you get, and what is the name of that product? You have
Osazone,
done your carbohydrate in college, so I'm asking for that. Tell me quickly.
Osazone, sir.
Osazone, yes. Osazone, what is an osazone? Osazone is a, here, you see, carbonyl group will react with one, that phenylhydrazine. Water will go and we get that phenylhydrazone. But this alcoholic OH group also will participate to give us a diphenylhydrazone, which is known as an osazone. But this is not an alcohol as such. If you take a simple alcohol, isolated alcohol, that is not going to react with phenylhydrazine. But in this case, it reacts because of this adjacent carbonyl group, which already gives a hydrazone first, and then there will be a special mechanism for this one. So you read this one, mechanism and other things. How do we get this osazone? And osazones, once upon a time, this were the preparation of osazone was also used to identify a particular monosaccharide, and also disaccharide, where this group was available. Because these osazones were highly crystalline substance, they have got a sharp melting point. And now one thing I'm asking you, do you see this arrow when I move it here?
Yes, sir.
You see the arrow, right? But when I have seen the, I have sent my video. I've sent 2 videos, but one video I find there is a lot of people have watched this one. Views are something like 58, 59 views are there. But the other video is only 12 or 13 views are there. That means second video, not everybody has seen it. Both videos are continuous for, so you see this. Now in the video, I find this arrow was not visible. Anyway, that is one thing that is actually we cannot, probably it does not record this, cursor, the pointer. Anyway, so this is osazone. Now you tell me, I've got another reaction, that is acetic anhydride. What it can do, what type of, which functional group will react with acetic anhydride and sodium acetate? Which functional group will react? Anybody? Hello? Which functional group? Yes? Nobody? Acetic anhydride? It is the OH group. Acetate will form. Acetylation of the OH group will take place. Anhydrous sodium acetate we have to take acetic anhydride. And here, what we have here, how many OH groups are there total? Just count in the glucose. How many OH groups?
5.
5.
So
So 5 OH group means we expect to get pentacetate, right? So glucose, now if I see the structure as such, 5 OH groups are there, so we get aldehyde group is not going to react with acetic anhydride. So we get what we write here, glucose pentacetate. Now why I have written structure for all of them, but I did not write structure for glucose pentacetate. Can anybody tell why I did not write that? Or it was my Or was it a point that there was no space there to write down the structure? What is your take? Huh? I have written all the structures of the compound that is formed, but I did not write down the structure for glucose pentacetate. Can anybody tell what is the idea, whether this space was a problem or something else? Anybody? Anybody? Not everybody should participate, not that 1 or 2% only. Nobody is having that answer, or the space was the problem for me to write down the structure there. Huh?
Maybe, sir. It is the structure will be complicated, I guess. It will
No.
be big structure.
Big structure, that is the space problem, that means you want to say, right? Huh?
Yes, yes.
Okay. I am not giving the answer now. What was the space problem or not, we'll see later on. But I am writing here glucose pentacetate. That is understood that we have got 5 OH groups, so pentacetate is the obvious product. There are other reactions also, I did not write it down. Reduction, say sodium borohydride. If I take reduction, that I did not write. That is why I say you read books. This is not a thing that has to be taught in MSc class. Reduction, what is going to affect? Which group will be affected? Sodium borohydride. Aldehyde group. What we will get from there? We get the OH group, right? CH2OH. That aldehyde will become CH2OH, and that will become all the alcohol, that is 6 OH groups, and that is called sorbitol in this case. All right. So with this we get. Now I come to, so this is everything that is there. One more slide. It is without animation. And okay, we come to now structure of glucose. Now, whatever structure that we have written, is it the correct structure that we have written? Or is it the actual structure that we have written? Yes or no? Huh? Yes? The structure that we have written and with which we have done all the reactions that is there, that we have shown, is it the correct structure or something wrong there or something other than this is there? Tell me.
Something other, sir. Sir, I think cyclized structure.
Cyclic structure is there. But that means the structure that I have written is wrong. You want to say
this
that?
is not wrong.
Huh?
This is not wrong.
It's not wrong.
Yes.
Then what is right then? Okay, we have to come to that right question, right answer. Okay, so we take, so this is important. From here we start our actual, though I don't know whether carbohydrate, when it is taught, whether this part will be taught by in the MSc class or not, I don't know, but I will take it because this, without this structure, we cannot go to the actual, the world of carbohydrate chemistry and their so we have to arrive at the actual structure of glucose, the real situation, what is there. And this molecule is a very simple molecule. The carbohydrate chemistry as such, when we say, is a very simple chemistry, but it is very unusual chemistry, very unusual. We don't observe this one with other type of molecules. Other type of molecules, whatever functional group they show, they also display their property according to that. But here this is a molecule or carbohydrate as such a molecules where you see the structure one way, but their properties are shown in a different way. It is the structure which will tell you what is going to be its properties. Means what will be what type of reaction it will. But this is a molecule, or I don't say this one only, glucose, all this carbohydrate chemistry You find the structure is one way and the properties are in a different way. How different? We'll come to that. So we come to the structure. First of all, whenever we take the structure, first thing that we have to know it is its molecular formula. How do we find out molecular formula? We get its molecular formula. How do we get the molecular formula? Molecular formula, we get it as C6H12O6. But how do we get the molecular formula determination? We have to do elemental analysis, what elements are present. Then we have to know percentage composition, we have to find out. Molecular weight you have to determine, and from their combination of everything, you have done the problem of that nature in class 11, 12. So that way we find out the molecular formula. And then the second part comes, the following reactions of glucose give further information about the structure of glucose molecule. So we carry out some reactions and which will give some idea about the structure. What are the reactions? These are the reactions that we have already done. Say one is, so this reaction was not there in your earlier chart. So reduction with red phosphorus, hydroiodic acid, red phosphorus. It gives you normal hexane. What is normal hexane? Is a straight chain 6 carbon atom compound, right? So from this information, what information we get about the structure of glucose? That means glucose is a 6 carbon atom straight chain compound. Yes or no? Yes or no?
Yes, sir.
So from this information, from this reaction, we get that glucose is a 6 carbon atom straight chain compound. So one thing is clear. Then we carry out some reaction with that where it shows that it is an aldehyde group. Say NH2OH reacts to give you oxime. Bromine water gives you gluconic acid. We react with Tollens reagent, Fehling solution. These reactions are also there. I did not write it. So these reactions show that it has got a carbonyl group, but carbonyl group present is a aldehyde group, not ketonic group. So contain a CHO group. So second thing we have got about the structure. Third, we take acetic anhydride and sodium acetate and it gives you glucose pentacetate. Now here it is not only the reaction, we also have to do the estimation. Estimation to show how many OH groups are being acetylated. That means we take acetic anhydride. After the reaction, the acetic anhydride, one part of the acetic anhydride will give you acetic acid. So from the quantity of acetic acid formed, we can estimate how many acetic anhydride or what equivalent of acetic anhydride is has reacted with glucose molecule, and we find that there are 5 equivalent which reacts ultimately, and so because it gives you pentacetate. So what does it show? That it contains 5 OH groups. This information we get 5 OH groups. Another thing, this 5 OH group, we know the properties of organic molecules. No organic molecule will have a compound having 2 OH group on the same carbon. That type of molecules are unstable. But what we find, glucose is a stable molecule. Because it is stable molecule, this 5 OH group must be present in must be bonded to 5 different carbon. So this information we get from here. Now with this, is already giving warning that it is going to end up in 10 minutes. Okay. So, we get 5 different carbon. So our structure is clear now. What is the structure then? We get, it is a 6 straight chain 6 carbon atom. One carbon is aldehyde group. Aldehyde group always has to be in one corner. So the first carbon atom aldehyde, the other 5 carbon atom must be having 5 OH groups. So for that we get this structure. All the above information show that the structure of glucose can be given as this one: CHO, then CHOH, 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 CH2H. So this is the structure that we can get. But here when we write down the structure, we find that there are 4 chiral centers, 4 chiral carbons appears here. When there are 4 chiral carbon, that means there will be 16 different configurations, and glucose will be one of them. So next, Next job will be to find out what is the arrangement of this this H and OH around this four carbon atom. That means the configuration of glucose. And for that one, again, we go to the next slide, configuration of glucose. Now here, it is a tedious process. Again, I'm not going to details of that process. If you wish, you can read from books like Finner and all, it will be there, how to get that configuration. But here, yes, anybody calling anything? Anybody? I heard some sound. Okay. Now, what is the configuration? Structural investigation show that the configuration of glucose, that is the arrangement of H and OH around 4 chiral centers, is as below. I am not going to the investigation, the details investigation. Investigation is there, is a very tedious chemical investigation, because after all, why we are doing this one? This is a method we are using, chemical method, the base chemistry. Nowadays, nobody does this type of investigation because everything, all the investigation are machine-based investigation. But this is an investigation which was done by the earlier generation of chemists, very, very early stage, at the very early stage where there was no machine, nothing, no NMR, no IR, nothing was there available. So that time this investigation was done, and they have done, they had taken quite a pain to get into this configuration. So it is investigated and ultimately found to have this configuration, which we know it. That means the OH groups, H and OH groups are arranged in this manner. Right, left, right, right. So this is the structure that we got. All right. So we have come up to this stage. This is the open chain structure of glucose. But what is the problem here? Is there any problem? Now, how to get structure when we, what is the structure? When we have the structure, structure is going to tell all its properties, yes or no? A property is shown by a molecule which can be exhibited, which can be displayed. You can get the experiment done in laboratory and get its properties. If we know this structure should explain all those properties. Yes or no? This is a common phenomenon in chemistry. Yes or no? Somebody tell.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. A structure, if a property that is displayed by the molecule has to be agreed by the structure. Okay. Now, what is the problem here then? We come to ring structure. But why you have to come to ring structure? What we see, the structure of glucose obtained cannot explain the following properties exhibited by the glucose molecule. Because some properties of glucose were studied, many properties were known. Some properties which we have already taken there is explained by the structure. But some other properties are not explained, cannot be explained by this particular structure. What are these properties? We come one by one. I think you have done your IRs, UV visible IR spectrum and all. Have you done?
Yes, sir.
Yes or no? Yes or no?
Yes, sir.
Okay. What is the information?
Yes,
what
sir.
information we get from IR spectrum? IR infrared spectrum. What is the information we get?
About the functional group present.
Yes, functional group present. And here what we find? What is the important functional group here in this molecule? We have got an aldehyde group. We have got OH group, right?
OH.
We have got aldehyde. which is very prominent. It shows all the properties of aldehyde. Aldehyde ketone are similar group. So if we take IR spectrum, this molecule should show the spectrum, peak due to IR, yes or no? But what we find, IR spectrum of glucose do not show any peak due to CHO group. This is a very, very important point. Very important point. Sorry. Now the structure, what we have written, aldehydic group is very clear. And aldehydic property, aldehyde, the properties also shows that. So this is the biggest, anomaly with the structure. It is showing the property of aldehyde. We have written the structure of aldehyde which satisfied all the molecular formula and this configuration, everything is satisfied. But when we take the IR spectrum, we don't find this carbonyl group present. Where the carbonyl group appears in the IR spectrum? It is at 1700 centimeter inverse. Have you seen any IR spectrum of any molecule? And this is a group, carbonyl group, means it can be carbonyl group in any form, whether it is ketone or aldehyde or acid or amide or any acid derivative. The carbonyl group cannot be missed by IR spectrum, never. It's very prominent peak and very easily detectable. We can see it. Have you handled or seen any IR peak for, IR spectrum for any molecule, anytime? Oh, sorry. This is our time is getting over. We are left with 1.5 minutes. Okay, tell me whether you have seen it or not.
Yes, sir.
Huh?
Yes, sir.
Have you seen the presence of carbonyl group in suppose some molecule having aldehyde or ketonic group? This peak is very visible. Okay, I am ending this this session. You will rejoin because my recording is there, so it will take little time. I stop here and you will rejoin.